I remember
When they canceled school?
when they canceled school for Precal.
Okay, so
No, I don't think it's right.
before take that to the front office, alright?
Huh?
Tell them we don't want school next week.
Oh, I want school every day.
Oh my God.
Vinny, is your
I
phone put
started on
up?
her iPad. Unless her iPad is green with
Is your phone put
Precal.
up? Luke, is your phone put up?
That's not good.
What's it back here?
All right, here we are, page 34 of our notes. And we are doing the airplane problem. So, let's see what's going on. We have an airplane. I know, what are you gonna call it? We have an airplane. And he is 5,000 feet above the ground. So here is my plane, and he's 5,000 feet above the ground. Does that make sense?
Yes.
When you do these word problems, you are always going to have a triangle that looks something like this. All right? Whether it's a tree or a lighthouse or whatever it is, we're going to have something standing up, and then something's going to be looking at something down here. So what do we got? The airport is over here. This is the airport. And the pilot is looking down at the airport. And his angle of depression is 17. I told you yesterday where to put that 17. Where do I put that 17? Right here. Always, always, always. That's where we're going to put the 17. Doesn't matter if it's an angle of elevation or depression. They're the same thing. That's where it's going to go. All right, everybody good? That's where we're putting it. Now, what do I want to know? How far is the plane from the port? What's X?
It's the iPod.
Isn't it right here?
Yeah.
Now, guys, I don't want you to overthink this. All right, don't overthink this. It says, how far is the airplane? This finger's at the airplane. Okay? How far is the airplane from the airport? This finger's at the airport. That's how far apart they are. Right? This would be the distance from the airport to the point on the ground directly below the airplane. All right? But this says how far from the airport is the airplane. All right, so what do we do? Once we get our picture drawn, then we have to decide whether I want sine, cosine, or tangent. Now, I know there are other options, but don't use them because you don't have them on your calculator. Just use sine, cosine, and tangent. So, here's my angle. Which side is this?
Opposite.
Opposite. Which side is this?
Hypotenuse.
Sine, cosine, or tangent uses opposite and hypotenuse. Sine. So sine 17, remember, the angle always goes with the sine, or the cosine, or the tangent. So sine 17 equals opposite over hypotenuse. Always clear your fraction. So x sine 17 equals 5,000. And I want to know what x is, so what am I going to do?
Divide by sine.
Divide by sine 17. So I'll go to my trusty calculator. By the way, that is a degree measure. So I think we're in degrees already, but let's just set real quick. Let's go to mode. Oops, I'm in radians, so good thing I checked. So 5,000 divided by sine 17. I got 17,101.52 feet.
Yep.
Charles? Eli, let's get our
I didn't make
calculators
it.
out.
Alright.
This one, yeah.
Oh, I wrote it down.
Oh, there it is.
Oh.
Alright, I need everybody having a calculator out. Kendall,
Derek,
I
was
need
that
your coat off.
5,000?
What?
Over
Uniform.
5. Oh, 6.
Alright, D. Find the height of a flagpole. So now we got a flagpole. Here's the flagpole. Find the height of the flagpole. So it's X, that's what I'm finding. It makes a shadow 13 feet long when the angle of elevation is 59 degrees. So we know that 59 is gonna go right here, right? Because it always goes there. And now I have to figure out where to put the 13. Now, what is the 13? The 13 is the shadow. Where do you see shadows? On the ground. So 13 is gonna go right here because that's where a shadow is. Shadows are right down there, right? So the shadow's on the ground. So here's my angle. Which side is this? Opposite. Which side is this? Adjacent. Sine, cosine, or tangent uses opposite and adjacent. Tangent. So tan 59
X over.
equals opposite over adjacent. Always clear your fraction.
13.
So we'll times by 13. And then we're done. Because we have X. X. That's what I want. I want X equals. And I have it. So 13 tan 59. The flagpole is 21.64 feet tall.
Mhm.
All right. Now I have a man looking at the top of the building. So here's my building. This is my building. Here's my man. And he's looking up at the top of the building. All right. The building is 48 feet tall.
Mhm.
And the man is standing 100 feet from the building. Now, do not overthink this.
Yeah, how about
He's 100 feet from the building. Where am I gonna put the 100? On the bottom. Very good. That's gonna go on the bottom. That's gonna go on the bottom. You guys, if I said how far am I from the back wall, wouldn't it be just that distance right there?
Yep.
It's not that distance, it's that distance right there. That's how far I am from the back wall. So this is how far the man is from the building. Yeah, we were gonna put that 100, is that 100?
Yep.
Yeah, if we were gonna put that on the hypotenuse, that would be the distance from the man to the top of the building.
Mhm.
And that could be the question, but it isn't. So the 100 goes down here. And what am I looking for? What's my X? The angle. Find the angle. Where do I always put my angles? Right there. When it's elevation and depression. Okay? So with regard to that angle, what have I got over here? Opposite, adjacent. So this is gonna be another tangent. So tangent, angle, the angle always goes with the tangent, equals 48 over 100. Now this one is a little different. This is the very last thing we did yesterday was a problem like this. Look at your notes. It would be question B.
Sine.
What did we do? There's no division, there's no multiplication. How do we get x by itself? Second inverse tangent, that's exactly right. I have to use my inverse function. We talked about this yesterday. Sometimes we use regular tangent, and sometimes we use second tangent. The only time we use second tangent is when our question is find the angle. When the question is find the angle, then you're always going to be using second something, inverse something. So if I inverse tangent, 48 divided by 100,
25.64.
my angle is 25.64 degrees. That's an angle. So it's going to have the unit. Mary, you got a calculator today?
Yeah, Leilani stole it. I didn't steal it. It was in my backpack. I didn't know.
You've been
I
walking
told
around
you
with
someone
her
stole it
calculator?
before. I didn't even know.
Crazy.
Put an air tag
I
on
told
it.
you it wasn't me.
All right. Okay?
What, you have a picture?
All right. Now, before we go on to switch gears into 4.3, I got a little practice quiz because the next time I see you, which believe it or not is Wednesday.
Wow, that's too long. Yes. Oh.
Who said yes?
Oh, that's it. That's
We're gonna have a little quiz.
a little.
I would suggest
Capital
that
using
you
your
pay
birthday.
real close attention.
Your birthday.
Take good notes here on this practice, and then spend some time in the next few days
I think you have a bad
doing it.
Oh, wait a minute. What is it?
Yeah, Willa says it's gonna be really
Yeah.
cold, so dress warm on Wednesday.
Yeah. Oh, it's supposed to be negative 11. That's all right. Yeah, so can't. No, step it outside.
Alright, did everybody get one? Alright, so I'm gonna put in my attendance, I think everybody that's coming is now here. Alright, so I'm putting in my attendance, let's see if you can do the first couple problems. In the first couple, you should be able to do without your big calculator. Now, you may need your calculator to help you with multiplication, or something. Let's do the first two problems. See if you can remember how to do the first two problems on the practice quiz while I'm putting in our attendance. Good, I think I got it. Okay. Who remembers how we do problem number one? Does anybody remember what we do? Willa?
I just did 5 times 180 over 6.
Exactly. So we know that pi, this right here, is 180 degrees. So we have, that's 180. Now, I like to do 180 divided by 6 because I know that is 30. And then 30 times 5 is 150. So that's how I do it, but you don't have to do it that way. You can do 5 times 180 divided by 6. It doesn't matter, you get 150 degrees. All right, everybody got 150? Now, how do we go the other way? How do we change 140 degrees into radians? Who remembers that? Derek?
Pi over 180.
Pi over 180 equals?
X over 140.
X over 140, that's exactly right. Pi radians is 180 degrees. How many radians is 140 degrees? So then if we cross multiply and divide, did you get 7 pi over 9
Yes.
when you reduced it?
Yep.
Alright, those should be super simple. Let's skip down to number 5. I'm going to do all the ones without a calculator first, so let's skip down to number 5. Anybody remember, doesn't really show what the question is there. Does anybody remember, this is the question, what's the arc length? Does anybody remember the formula for arc length? Arc equals, yep, radius times radians. Now, I want you to look at that. Okay, clearly the radius is 4, right? Nobody's got an issue with that. I want you to look at that angle. Does it have a degree mark on it?
No.
That means it is a radian measure. So your answer is just going to be 4 times 1.8. Because arc length is radius times radians. So 4 times 1.8 is 7.2.
Yep.
And the unit on that would be inches, because that was inches. So the arc length is 7.2 inches. What angle measure describes west, northwest? Okay, so I'm not going to draw the whole compass, but I'm going to draw part of it.
295.
Now, I remember on my compass, these are the big ones, right? Those are the big angles, north, south, east, and west. And if we're talking about west, northwest, I'm going to go ahead and put in, this is my northwest line. Would everyone agree with that? And then west, northwest would be this one right here, because it is on the west side of the northwest line. So this is west, northwest. This one would be north, northwest. But I want my dash line, okay? So remember, the quadrants are all 90s, so that's 270. When I draw in the northwest line, that splits this quadrant in half, so that's 45, and the whole thing here is 45. When I draw in that diagonal, I'm splitting the 45, so this is 22 and a half, half of 45. So 270 plus 22.5, so 292.5 degrees. Now, you can do any direction that way, right? Start with the compass and then start dividing it. The first division, like if I drew in this division, These are 45s. When I start dividing those become 22 and a half. All right, and you just count around till you get where you want to be. All right, fill in the blanks. I don't know anything except that the cosecant is 4/3. Now, you guys, if the cosecant is 4/3, then what does that mean about the sign?
3/4.
3/4. And what do I know about the sign? Sine is opposite over hypotenuse. So if the sine is opposite over hypotenuse, then would you agree this side is 3 and this side is 4? But in order to fill in the rest of these, I need that side. So how do I find that side? Pythagorean theorem, which is x squared plus 3 squared equals 4 squared. So x squared plus 9 equals 16. X squared equals 7, so x equals the square root of 7. And now I'm ready to go. What's cosine? Adjacent over, adjacent over hypotenuse. What's tangent? Opposite over adjacent. Now, I did not label these. Feel free to do that if it helps you guys. It helps you keep track of what's what. Go ahead and label this. And then as soon as you do these, you can do those. Because if the cosine is root 7 over 4, the secant is 4 over root 7. And the cotangent, the cotangent is root 7 over 3. And then if I want to get an A plus, I'm going to go back and simplify this one. 3 root 7 over 7. And this one, 4 root 7 over 7. All right, let's turn it over and look at number 8. We'll come back and do the calculator ones in a minute. Let's look at number 8. What's the cosine of pi over 4?
180.
All right, so let's just pause for a second. Okay, what do I do first here? Convert that into degrees. So pi is 180. Divided by 4 is 45. So I'm looking for the cosine of 45 degrees. Now, every time we have a quiz or test over this, somebody will put 45 down as the answer. 45 isn't the answer. 45 is simply the problem in degrees. So now I'll draw my triangle, same one I drew over here, only I know that's 45. Right? If that's 45, this one's 45, and that's a 45, 45, 90 triangle.
Yep.
And then I know my sides are 1 root 2.
She said she had cookies.
I'm doing cosine. Cosine is adjacent over hypotenuse. 1 over root 2. But then again, if you want to get a plus, you're going to do square root of 2 over 2. Guys? 180 divided by 4. All right, and finally, the last one without a calculator is number 10, which is the backwards of the one we just did. We have an angle out there, and we know that its tangent is root 3. I'm gonna draw a picture of that. I'm gonna draw the same picture I draw every time. Here you go, there it is, there's my angle. Now, if the tangent is root 3 over 1, what do I know about my triangle? What's tangent? Opposite over adjacent, right? So this would be the square root of 3, and this would be 1. Opposite, adjacent. And I recognize those numbers. Those are on my orange sheet. So this guy up here is a 2. Now, you can make it an X and do the Pythagorean theorem if you want, but you don't need to because that's one of your special triangles. But you can. It'll come out to be 2. And you don't really need it because you're trying to figure out what that angle is. So if this is a 30, 60, 90 triangle, look at those numbers, that's a 30, 60, 90 triangle. What angle is across from the root 3? 60. Guys, you gotta memorize that orange sheet, look at it. Across, I'm talking about across from the 60 is a root 3. I even wrote it at the bottom of the sheet. I said 30 goes with 1, 60 goes with root 3, 90 goes with 2. So the answer to the problem is 60 degrees. All right, so all of those problems that we just finished, you should be able to accomplish with just a baby calculator, because it's just arithmetic stuff. Now I need my big calculator. Number 3, 211.764 degrees, and I want to convert that to degrees, minutes, and seconds. Okay? So anybody remember how to do that? It's super simple. Type in the degree. So type in 211.764. Charles, get your head up. Now I know your parents. Right?
How does he really feel?
I sold some tickets to his parents. All right, what do I do with 211.764? Now I got it in my calculator. What do I do? Second angle, DMS, degrees, minutes, seconds. There's no work, you just type. So 211 degrees, 45 minutes, and 50.4 seconds. So I type in my angle, then I go to second angle, click down to DMS, and there it is. Now, what do I do if I'm starting with degrees, minutes, and seconds? So now I'm starting with this. Well, I type that in, right? So 153,
Second.
how do I get the degree mark? Second angle, and right there it is.
19.
And then 19, second angle, click down to option 2.
57.
And then 57,
Alpha.
alpha plus. And we get 153.3325. Where's your calculator? First of all, it's gonna freeze out in your car. You need to have a calculator, you know? Come on. Going to pass.
Why didn't you bring me back $10?
It says that at least we're getting one, so if they die, let me know, but it's still functioning. All right, secant 200. I'm gonna type this in on my calculator. 1 over cosine. Secant is 1 over cosine. So I just type that in. 1 divided by cosine 200. Negatives are okay. I get negative 1.0642 if I round off to the nearest 10,000. 4 decimal places. Wow, you got a calculator back there? On time, with the calculator. It's a new minus. Love it. All right, number 11. This is not a word problem. There's no word problem on your quiz, but it's a picture that looks like our word problem pictures. Like, here's a pool 5 feet tall. And here's a rock out here. Angle's 37 degrees, and I want to know how far the rock is from the base of the pool. It's like a word problem picture. So what do I figure out? What do I think about? I'm going to write an equation.
You're going to use
And the
10.
equation's going to be sine, cosine, or tangent.
Tangent.
So I'm going to figure out, here's my angle. Which side is this?
Opposite.
Opposite. Which side is this?
Adjacent.
Adjacent. That means tangent. So tangent 37
Equals 5.
equals 5 over x.
16.
And then I'll multiply to get rid of my denominator.
Divide.
And then this one I have to divide.
37.
To get x by itself. So 5 divided by tangent 37, 6.64.
Let's take a break.
Will we just say units?
You don't even need anything. It's not a word problem, so we don't need to worry about it. But that wouldn't be wrong. It is. It's something.
What was it? Did we skip
What did you say?
Okay. All right, let's tuck those aside. Please don't lose it.
Oh, negative.
If you care to practice again, all the discussion has been videoed. You can go back and watch the video and go through the problems again, if you care to do that. What we're gonna do now is move on to 4.3.
No, No, you don't mind. Because it's not a word problem.
It's not a-
All right.
Okay.
6'3", yeah, 6.635, 6.
Oh, okay.
All right. Keep that yellow page out though. Phil, why not?
All right. So here we go.
That you have to work on that.
This should be my national day.
This problem is very similar to ones we did before, and in fact, there was one on your quiz practice that was sort of like this. Now, the difference is all of our angles before were sitting in quadrant 1 like this. They all look like that.
God bless.
This angle is all the way around to quadrant 3. The good news is that doesn't change hardly anything about what we do, all right? Now I'm getting ready to tell you something pretty important, so let's zero in, lock in, as you say.
Lock in.
I need a triangle. I don't know if you paid attention or not, but every single problem we've done, except the ones where we're changing from degrees to radians, every other problem we've had a triangle for. We always draw a triangle. When I draw my triangle, I always draw it so that it is either sitting on the x-axis or hanging on the x-axis. We call it the butterfly bow tie. Every triangle you draw has to be either that one or that one or that one or that one. Okay, every one you draw. So that means when you have a situation like this one, don't go sideways to make your triangle. That would be wrong. You have to go up to the x-axis because it has to look like that. Every time. Okay? All right. So now I got my triangle. If that is the point, this is the origin. If that's the point, -3, -4, doesn't that mean that I counted over -3 and down -4? So this side of the triangle is -3. And this side of the triangle is -4. Now I know what you're thinking. You're thinking, Mrs. Ford, sides of a triangle can't be negative. And you're right. But I'm going to leave those negatives on there because this tells me I'm going left and down. Okay? So those negatives are like directional things. Negative is left, negative is down. Now what about this side of the triangle? Well, that's missing. I don't know what that is. How do I find a missing side of a triangle? How would I find that side right there? Pythagorean theorem. So I'm going to have 3 squared plus 4 squared equals x squared. Now, I did this problem yesterday and somebody said, what happened to the negatives? I'm squaring. What happens to the negatives when you square? They're gone, right? They're gone. So you can put them in, I don't care, but they're going to disappear because -3 times -3 is +9. And -4 times -4 is +16. So 25 equals x squared, and it looks like x is going to be 5.
Yes, sir.
Now, this can be negative. If you're left, that's going to be negative. This can be negative. If you're down, you're going to be negative. But the hypotenuse is always positive. The hypotenuse, this guy right here, is always positive. So I've told you two really important things today. I've told you that every triangle you draw is going to be a butterfly bow tie. And every time you do the Pythagorean theorem and get a hypotenuse, it's positive. The hypotenuse will never be negative. Never. That number will never be negative. This can be negative, and this can be negative, but that will never be negative. Now I'm ready to go. My angle's always here at the origin. So if that's my angle, which side is this? Opposite. Adjacent. Hypotenuse. And now I fill them in, just like I did before. So what sign? -4/5. So remember the other day when we were getting negative answers and people were saying, oh, can that be negative? Yes, it depends where you are in the coordinate system. If you're down here, you have some negative stuff going on. What's cosine? -3/5. And how about the tangent?
4.
I heard some of you catch yourselves. It's actually going to turn out positive. Why is it going to turn out positive?
Because it's both negative.
Because it's negative over negative. And then these are still the reciprocals, so this is going to be -5/4, -5/3, and 3/4. Now remember, in a fraction, where you put the negative doesn't matter. I always put mine on the top, but you could write 5 over -4, that's perfectly okay, if that's what you want to do, that's perfectly all right. You could even write -5/4 and kind of have it in the middle, that's okay. You just need a negative in there somewhere. Okay? All right, let's look at B. Problem B. All right, this time given looks like this. My angle's all the way around. So I'm going to make my triangle. And when I make my triangle, I'm going to go straight up. Is that all right with everybody? And if that's the point, +1, -2, then what's this? 1, and what's this? -2. 1, -2. And now I'm going to find that again. Right? So I'm going to have 1 squared plus, technically it's -2 squared, but it's the same as 2 squared, equals x squared. So 1 plus 4. It looks like this time I'm going to get square root of 5. Right? And now I'm going to fill in all those blanks. So here we go. Remember, your angle is always the one at the origin. Always the one at the origin. So this side is going to be opposite. This side's going to be adjacent, and this, of course, is the hypotenuse. All right, so what's my sign? -2 over √5. I know that needs fixed, but -2 over √5. How about my cosine? So that would be my cosecant. My cosecant would be negative root 5 over 2. What's my cosine? COS. 1 over square root of 5. So this one's square root of 5 over 1. And how about my tangent? What's my tangent? Negative 2 over 1, which is just negative 2. And the cotangent is 1 over negative 2. And then we'll fix these. So do you see how in that problem, well, this one too did, the first one we did too, the one I raised, some of the answers are positive and some of them are negative? Then that's gonna happen. If you're not in quadrant 1, the triangle is not up, if the triangle's here, everything's positive. But if it's anywhere else, you're gonna have a few negatives floating around. Bo?
When you change it from the reciprocal, you're doing it from the original number,
Yes,
not
we
the.
talked about that the other day, because if I flip this, I'm gonna have a radical in bottom. So it's easier to flip this. All right, we're gonna do one more, ready? Letter C. Last one for the day, so hang in there. Let's see if we can get it.
Got it. Do like I said.
My point this time is negative 1, 3. Here we go. It's not a root 3. If it had been a root 3, you're exactly right. It would be. All right, so what's the first thing I do? Step 1. Here's first draw. That's right. Daria says I need my triangle. So I'm going to drop a perpendicular straight down. That's how my triangle has to go. And then I should be able to label the sides. So remember, that's the point negative 1, 3. That means this is the origin. We went left 1 and up 3. And then I should be able to find the missing side, Pythagorean theorem. So negative 1 squared and 3 squared equals x squared. So 1 plus 9 equals x squared. Did you get the square root of 10? So now we're actually ready to write our answers as soon as we figure out what's opposite, adjacent, and hypotenuse. Obviously, this is hypotenuse. Remember, your angle is always at the origin. So that's going to be your angle. Which means this is opposite, and this is adjacent, right? So fill them in, let's see if we all come up with the same answer. Make sure you keep track of your negative sign. Jack, you got it done?
Yeah.
Cole, you got it done? Zane,
Unzippy.
wonderful, wonderful
Yeah,
news.
you're right.
Now get your thing out of your car. Bring it. All right, that's it for the day.
How you doing? You still acing all this time? Good girl.